Our next bell ringer review. So again, a lot of these we're trying to practice without a calculator. Jacqueline sells hamburgers $3 and cheeseburgers $3.50. I don't know if you're getting it yet. Hamburgers and cheeseburgers, there's money. I am going to just assume this is going to be a system. So that means I'm looking for two equations to be able to solve for one of the others, because indeed it asks how many of these were hamburgers. So I have hamburgers and cheeseburgers. One afternoon, she sells a total of 24 burgers. So that means a total of 24 hamburgers and cheeseburgers for $79. This one gave us our totals, and the things that match together are a little more mixed up than we've done in the past. So $3 for hamburgers, $3.50 for cheeseburgers. This one does not state without a calculator, and that is likely because of those nice decimals. But let's see how far I can go, or we can go, because again, we're pushing it. If it doesn't, it's not hurting anything if you miss it off the gate, especially since you get 3 shots at these bell ringers. So try your best. We need things to cross out. I'm going to multiply by -3 at the top, again, because I'm trying to do this without a calculator. And the 3.5 will be a little messier. Not impossible, but a little messier. So -3 times h, -3h. -3 times c, -3c. -3 times 24 is going to give us 72. And again, as a reminder, 24 times 3, 3 times 4 is 12, 3 times 2 is 6, plus 1 is 72. So 3 times 4 and 3 times 2. Carry over. We are now going to pay attention to these two, work straight down and cross things out. I'm going to cross out the hamburgers. That's going to give me, I had $3.50, I spent 3, so I'm going to 0.5 for a cheeseburger equals 79 minus 72. It's going to give me 7. I'm going to divide by 0.5. So if you think about money, 0.5 is 2 quarters. How many 2-quarter stacks can you make with $7 worth of quarters? So 0.5 is the same thing as 1/2. You can't divide by a fraction, so you're going to take the reciprocal. How many 50-cent chunks would you have in $7? If you had 4 quarters in a stack, you'd have 7 stacks. If you cut all of those in half, you would end up with 14 stacks. So we have 14 cheeseburgers. Go back, read your question. What are we looking for? We're looking for hamburgers. If it's multiple choice, that answer is going to be there. So just be careful. We're going to go figure out if I had 14 cheeseburgers but 24 total, then I'm going to have 10 hamburgers, because hamburgers plus 14 equals 24. Subtract 14 from both sides. Hamburgers equals 10. That is the answer to this question. Hamburgers equals 10. Number 2, find the perimeter. Perimeter is the sum of all the sides. In this case, this side is we're going to travel 2y and we're going to travel x. So that's addition. 2y plus x. And then our vertical or up and down side is going to be just x. So since it's x on this side, we know this side will also be x. And since this side is 2y plus x, this is also going to be 2y plus x. We're going to take all of this and add it together. So 2y plus x, 2y plus x, because it's twice, another x, and another x. And that's all 4 sides. So I have 1, 2, 3, 4, 4 x's, 1, 2, 3, 4, plus 4 y's, and it can be 4x plus 4y, or 4y plus 4x would be correct for the sum of all 4 sides. There's no rule as to whether x or y has to go first in that case. So both of these are good answers. There's 1, 2, 3, 4 x's, and there's 2 y's plus 2 y's, again 4 y's. Number 3, the graph of a linear function has a y-intercept of -4 and passes through the point 5, 6. What is the slope of the line? Remember, that's the differences in y's, which can be notated as this, over the differences in x. And I call this out because we haven't talked about this in class, but that triangle means difference. So just the idea that it's the y minus y over x minus x, or if you do like we do, or like I like to do, 5, 6. And then as a y-intercept, again, we know that that means our x value is 0 and our y value is that -4. And we're going to subtract the x's and we're going to subtract the y's. Because remember, I like to stack them, work straight down, and just know that y goes on top. 5 minus 0 does give me 5. Minus minus is going to make that a positive 10. 10 over 5 will give me a 2. So the slope of the line is a positive 2. This is likely to be calculator inactive. Either way, you have to know that the y-intercept, the x value is 0. You would have to be able to plot both those points and then count between the two. And you could graph 0, -4 and graph 5, 6 on the large piece of graph paper and then count the rise and count the run. And then you should end up here and still end up with 2. So again, a little bit of other options. You can use your graph paper if you'd like. Okay, so number 4, this guy you have to use Desmos because it is a line of best fit. And we are going to plug that table in to Desmos because we have our X values. Hours practice is what we control. That's our input. And then what happens for that ideally is our points scored. That's our output because the point score depends on, so it's dependent, how many hours we practice would be the ideal way that tables are or should be set up. Logically, sometimes there's some outliers in every bunch, right? So we are going to write the rule. That was one of the words that I made sure was on that question to make sure you understand that when it asks for a rule, it is indeed just asking for the equation. It's just another way, kind of like slope is rise over run or coefficient of x or rate of change. A rule is just the equation. And remember that when we're looking for a linear, it usually will tell you that it has a linear relationship, or you would identify, in this case, because it's not a perfectly linear table, it's going to have to tell you what kind of rule it wants. So we're going to plug in our table, y sub 1, and you could get it from copying and pasting. But do make sure, because sometimes I've watched this do crazy things, and all of a sudden you'll start deleting these and not completely close the calculator and start over. If this says y2, this needs to say y2. If this happens to say y3 or whatever other number, y sub 1 needs to match whatever y sub up here is. So our parameters, this equation, this does tell us to 100th place, so to the second decimal place. So we're going to do our m value, which is down here, is going to be 0.64. And then we have x, and then plus 9.41. Because that 7 after that 0 is going to round that up. 7 here would round that up. We're only going to the 100th place, so that's just 2 spots over. So again, 0.64x plus 9.41. And that'd be y equals, or we could call it f of x equals, or whatever, all the same. Number 5, without a calculator, write the equation of a line perpendicular. So that's opposite and reciprocal, passing through -8, 12. This is a typo on my part, for sure. I was trying to do too much at one time. Equals 12. Passing through -8, positive 12. We want to isolate y, move it over, because we want to get it in the slope-intercept form to be able to identify our slope. Our slope is 2, but we need the opposite reciprocal of 2. So 2 to become opposite is going to be -2, and then to flip it is going to be a -1/2. You cannot just reciprocal or just opposite. No, we'd rather work with a -2, but we're going to work with a -1/2. Our x value is a -8, and our y value is a 12, so we're going to do just like before. 12 equals, we're going to go -8. Whoops, trying to keep my colors straight. I'm not double used. Our x value was -8, and our slope is 2. Sorry, I mixed those up. Hopefully you're still tracking what I'm doing. And we're looking for our new y-intercept of the new line. -8 times 2, -16 plus b equals 12. We're going to add 16 to both sides, and we're going to have 28 equals b. So our new equation is y equals a -1/2 x plus 28. Last but not least, number 6, without a calculator. Fractions are favorite, don't panic. So 2 over 5x. Then we're going to multiply it by -2. So 2 over 5 times the -2. When we multiply, remember, we're going to work straight across the top. -4, and straight across the bottom, over 5. So it's going to be minus 4 over 5 equals a -3. I'm going to have to add that 4 over 5. Some of your work I saw, and it was beautiful and great job. Awesome job. Difference in multiplying versus adding. So -3 plus 4 over 5. They have to have like denominators. So that -3 over 1, this needs to become a 5 so I can work straight across and end up keeping that 5. To make a 1 of 5, I multiplied by 5. So I'm going to multiply that 3 by 5, and I'm going to get a negative 15. If I owe you 15 and I pay you 4, then I'm going to owe you 11. So a negative 11 over 5. At that point, my 2 over 5x is still hanging out over here, equals a negative 11 over 5. We're going to multiply. You can multiply by the reciprocal. Like super mathy way is flip this puppy and keep on rocking and rolling. Times 5 over 2. Because you can multiply fraction that way. If you want to do it one at a time, this is divided by 5. So we're going to multiply by 5. And then you're going to have 2x. So then you're going to divide by 2. So a negative 55 over 10 is going to give me a negative 5.5. Anytime you divide by 10, it's just moving your decimal to the left. Though this does not have a decimal, all whole numbers have that imaginary decimal at the end. So it's just going to be a 1 to the left. Just like dividing by 100 when we were talking about exponential functions moves the decimal 2 to the left because there's 2 zeros. All right, guys, come find me if you have more questions.